Okay, so in this question, we've got a parametric curve C, parametric equation using x is 3 tan theta, y equals 4 cosine squared theta. Now what we're interested for this question is the shading region S. And what we're going to do is we're going to rotate it around the x-axis by 360 degrees. And then we're going to find the volume of it. So let's just draw up a picture of what we'd end up with. So we'd end up with a shape that looks something like this, and then with the x-axis going through it, and then with a shape that looks something like that. Not the greatest of picture, I know, but that's the best we got for today. So how do we go about finding the volume? So the volume of this is what's called the disk method, and the formula for that is y squared dx, disk method. And that's what you use every time you rotate something around the x. You can also rotate it around the y, but for today we're going to rotate around the x. Okay, so let's see what we can do with this formula here. So pi, no problem. Y squared, no problem. Dx, that's a problem, because y squared is 4 cosine squared theta, but that's in the theta world. This integral is in the x world. So we need to get that into the theta world. So how do we do that? Well, what we can do is we can set it up like this. So y squared and then dx, and if we multiply it by d theta over d theta, we've got a chance of getting into the theta world. Because if we can find out what dx d theta is, plug that in and then just leave d theta at the end, then we're completely in the theta world. So dx d theta. So let's have a look what we can find for that. So that basically just means the derivative of x with respect to theta. Well, that we will use this formula here. So basically we're looking for the derivative of 3 tan theta. Well, we know that as 3 secant squared theta. So that's good. And then y squared. So y squared is 16 cosine to the 4 theta. Okay, good. Next thing we need to do is put in our limits of integration. So we'll do that on this next line and put in these y squareds and dx and d theta values. So we've got pi, y squared, 16 cosine to the 4 theta, 3 secant squared theta. Then we've still got the d theta. Okay, so now we're in a much better position. Now we're in the theta world. Okay, so our limits of integration. We can't just put 0 to 2 pi in, because that won't work, because our theta is in between 0 and pi over 2. So what do we know about theta? Well, we know we've got a value for x here on our parametric equation. So we know that x can be 3 here. So what we can do is plug in x equals 3 here. So x equals 3. And then we can say 3 equals 3 tan theta. That means tan theta equals 1. Divide both sides by 3. So therefore theta equals inverse tangent of 1, which equals pi over 4. Okay, therefore we can put our limits of integration in. So we'll start from 0 and to pi over 4. Okay, right, can we integrate yet? Don't think we can. 3 secant squared theta we can do. That goes well with a tangent, but we've got cosine here. So a little bit of algebra required. So 3 secant squared theta, which we've got here, we can say that is 3 over cosine squared theta. So I reckon if we plug that in there, give us a chance of crossing out our cosine to the 4s. So that equals pi integral 0 to pi over 4, 16 cosine to the 4 theta, 3 over cosine squared theta d theta. Okay, now we can do a cross cancellation. So let's put that in. It's pi times pi over 4 limits of integration. Now let's 16 times 3, 48. Cosine to the 4 divided by cosine squared is cosine squared. And then d theta. Okay, now we need to plug in a trig identity for cosine squared. Well, we do know that cosine squared theta is the same as a half times 1 plus cosine 2 theta. Okay, so that puts us in a better place. We can put that into there. So that equals pi times pi over 4, 0, 48 times cosine squared theta. That's a half 1 plus cosine 2 theta, d theta. Okay, let's bring the 24 out front and then we're ready to integrate. So that equals 24 pi, 0 to pi over 4, 1 plus cosine 2 theta, d theta. Okay, just integrate these two straight off. So that gives us 24. Now we're working with limits of integration here, so we'll just set up a nice little square bracket. 1 in the theta world, integrated is theta. Cosine 2 theta. Well, that's going to give us integral of cosine is sine. The 2 theta stays. And then by the chain rule, or the reverse chain rule, obviously, because we're in integration, instead of multiplying by 2, we now need to divide it by the 2. So that's a half sine 2 theta, pi over 4 to 0. Okay, right, now let's work this out. When theta is pi over 4, we've got 24 pi over 4 plus, okay, so theta's pi over 4, so that means we've got sine times pi over 2. Now sine of pi over 2, that's 1. Let's just write that down over here. That's by the unit circle. So that gives us half times 1 is a half. Half times 24 gives us 12. Okay, so let's just simplify that up a little bit. So that will give us 6 pi plus 12. Oh, I missed out the pi here as well. Let me just put that in. So that's pi squared plus 12 pi. Okay, see how easy that is to make a mistake. So that's 24 pi. Let's just write that 24 pi in there a little bit neater. Okay, 6 pi squared plus 12 pi. Okay, so that's what we got so far. Now, because this will make the shape of a cone, we need to take the cone out of it as well, using this formula here. So basically what we'll have is 6 pi squared plus 12 pi minus the volume of the cone. That will give us the total volume of that. So 1/3 pi r squared. So 1/3 pi r squared h. What do we plug in for that? Well, for the r, for the radius, we're going to plug in 2, because y is 2. So we use this formula here. So 1/3 pi, 2 squared. Now the height changes. So it goes from 3 to 5 over 3. So all we're doing here now is plug in 3 minus 5 over 3. Okay, let's see what we get here now. So 1/3 pi times 4 times 3 minus 5/3. 3 minus 5/3 is 4/3. Okay, let's do this quick. 1 times pi times 4 times 4, that's 16 pi. 3 times 3 is 9. So now we've got 6 pi squared plus 12 pi minus volume of the cone equals this stuff. So 16 pi over 9. Okay, that's going to give you an answer. But we can do better. We can just simplify this up a little bit. So 6 pi squared we have to leave, plus, now if you make this over 9, multiply the top by 9 and the bottom by 9, so we get 108 pi minus 16 pi all over 9, which equals 6 pi squared. 108 minus 16, 92 pi over 9. That will give you the volume of this whole shape here when rotated around the x-axis. Okay, thanks for watching.